All right, today we're going to get right into it and break down the very building blocks of reality. We're talking about the atoms that make up you, me, and, well, everything. And trust me, what we're about to find might just completely change how you see the world. So let me start by asking you a question, and I want you to really think about it. It sounds simple, maybe even a little silly, but here it is. Have you ever, in your entire life, really touched anything? I know what you're thinking. Of course I have. I'm sitting in a chair, I'm holding my phone. But here's the thing. According to the fundamental rules of physics, the real answer is no. You haven't. And we're going to break down exactly why. To get our heads around this, we need to zoom in, I mean way, way in, to find out just how ghostly our own bodies really are. Just look at this number for a second. 99.999999%. It's a huge number, right? Almost 100%. Well, that's how much of every single atom in your body is, get this, completely empty space. That means your hand, your brain, everything you think of as solid, you, is made of atoms that are almost entirely nothing. The feeling of being solid? It's kind of an illusion. And here's how insane that is. If we could somehow just squish all that empty space out of you, your entire body would shrink down to a particle, so small you couldn't even see it, a tiny speck of dust. But you'd weigh exactly the same, a tiny, super dense you. Mind-bending, right? So, okay, if it's all empty space, what's actually in there? What's going on? To understand that, we've got to look at how an atom is built. And it's basically like a tiny, tiny solar system. It all comes down to the atom, the basic unit of all matter. And yeah, thinking of it like a solar system is the perfect way to picture what's happening. So right in the middle, you have this incredibly dense nucleus, that's our sun, made of positive protons and neutral neutrons. And then, zipping around it like planets on crazy orbits, are these tiny, negatively charged electrons. And they are moving at almost the speed of light. It's that massive distance between the nucleus and those speedy electrons that creates all that empty space we were just talking about. Okay, hold on. This brings us to a huge, huge question, right? If we're all just these collections of atoms that are mostly empty space, why do we feel solid? Why doesn't your hand just pass right through a wall? I mean, seriously. If your hand is almost entirely empty space, and the table you're about to put it on is also almost entirely empty space, why doesn't your hand just pass straight through it like a ghost? What's going on? Well, the answer is wild. It has nothing to do with solid stuff hitting solid stuff. It's all about those tiny electrons we mentioned. They create this invisible force field. Think about it like this. You know when you try to push two magnets together the wrong way? You can feel that weird invisible cushion pushing back, right? You can't see it, but you feel it. That's exactly what's happening on an atomic level. The negative electrons in your hand are literally pushing away the negative electrons in the table. So get this. What you feel as touch isn't contact at all. It's a sensation of force. It's the repulsion between trillions of your electrons and trillions of other electrons. You have never, ever truly touched anything in your life. You're literally floating on a cushion of electric repulsion. Okay, so we're untouchable ghosts made of mostly empty space. Cool. But the story gets so much bigger. To really understand what we're made of, we have to pull the camera back, way back, and look at our cosmic origin story. This is literally your cosmic family tree. It all started billions of years ago. A massive star reached the end of its life and exploded. It basically sneezed all these new, heavier atoms out into the cosmos. Over billions of years, that dust clumped together, formed planets, including our own Earth. Then, those atoms became the soil, which grew the food you eat, and now, those exact same atoms are you. Let that sink in for a second. The very iron atoms in your blood that carry oxygen, the calcium that makes up your bones and your teeth, every single one was forged inside a star that died long before our sun was even born. You aren't just on the Earth, you are the Earth. You are recycled stardust. Okay, so we're made of ancient stardust. Got it. But how does that stardust build everything around us, from a glass of water to a bar of gold? Well, for that, we need to think of atoms as the universe's Legos. See, it turns out atoms are super social. They really don't like being alone. So they're constantly linking up, bonding together, and building bigger things called molecules. And water is the classic example, right? You just snap two little hydrogen atom Legos onto one oxygen atom Lego, and boom, you get H2O. Every drop of water in the ocean is just trillions and trillions of those little structures all stuck together. So what makes a hydrogen Lego different from, say, a gold Lego? You'd think it would be super complicated, but it's shockingly simple. It all comes down to one thing: its atomic number. That's basically its unique DNA, and it's just a count of how many protons are in its nucleus. I mean, look at this. It's incredible. An atom with just one single proton, that's hydrogen, the lightest element, the stuff that fuels the sun. But an atom with 79 protons, that's gold. The only real difference between star fuel and a precious metal is just a number. And that leads to this just beautiful, simple idea. Everything in the entire universe, the air you're breathing, the device you're watching this on, you, it's all made of the exact same three tiny things: protons, neutrons, and electrons. It's all the same stuff, just in different amounts. So that brings us all the way back to you, a temporary thinking, feeling collection of stardust that's been on an incredible journey for billions of years. And long after you're gone, those atoms will continue their journey, becoming part of a new tree, a new cloud, maybe even a new star someday. So that just leaves one final thought. What will your stardust become next?